Thank you everyone for dropping by. In case you didn't know where you are and which ballroom we're in, we're talking about heads-up display, or how to empower developers and create a scalable user interface inside of Unity using third-party tools. So first of all, you may or may not know who we are, probably don't. Some of you we kind of recognize, some we don't. My name is Gerald Orban. I'm a programmer at Blackbird Interactive. I've been around with the company since inception, actually, and I've been deeply involved with its user interface and heads-up display evolution. And some kind of neat little fact about me, in my spare time, I actually like to build giant racing robots, just like this thing, actually.
My name is Lance Mueller, and I'm the user experience artist at Blackbird Interactive. I've been there for about 1.5 years now. It's pretty awesome, and we got some cool stuff to show you, so let's head on in.
Oh yeah, and by the way, this is also our first full-scale talk in front of an audience ever, so please forgive any kind of mishaps or staring at a blank space kind of babbling. It might happen. So, what are we going to talk about today? So, Unity is a fantastic platform. We started using it about 2.4, 2.5 in circa 2010. And first thing we discovered, there's actually a plethora of different tools available for you to use, especially with the version of user interface. We know it doesn't really have a very good implementation and ability to create user interface right now, but it looks like there's something really cool coming down the pipe. But we kind of grabbed whatever we could find on the asset store, lopped a bunch of icons to really drive home that the community is being very, very good at providing us interesting and unique solutions. Us ourselves, we've used a couple of these solutions ourselves throughout the evolution of our heads-up display, and I'll actually go through and talk a bit about which solutions we used and how we utilize them to the best way possible. And further to that, we want to talk about scalability. Whatever solution you do choose, it should be able to kind of take whatever kind of punishment your creative force at your game company actually involves with. So, best case example is our game was a relatively small scale, a couple units on the screen at once, not a whole lot of icons, not a lot of feedback, not a lot of animations, and creative director comes up. Gerald, we want 100 different units on screen at once, so we want lots of icons. So we'll talk to you about how we managed to scale up our heads-up display to actually support a ridiculous amount of icons and things on screen at once. And I talked about developer empowerment when I introduced this slide. So your best friend, the programmer who usually sits there and breaks his back for you to make all these things happen, doesn't need to be there all the time to make sure that you can actually create the user experience and heads-up display that you want.
So what we needed from our HUD is 4 basic things. We need to be able to easily debug the system without the programmer being there every second. We needed this information available at runtime, in the editor, and whenever we might need it. And then we needed to be able to quickly iterate on these things. Being able to take assets, whatever asset we needed. If somebody wanted to change the look of something, we need to be able to do it very quickly. Next, we wanted to organize these things into HUD layers. We're going to be talking about that a little bit more as we get into the talk. But it's just an organization, a way of organizing this information easily and effectively so that you can debug it and iterate on it. And organizing hundreds of icons, as you can imagine, it's a big task, so we need to really think about how we're going to organize those things. So, HUD layers. At the very beginning, we wanted to take inspiration from something that we all know and use, something that's easy to use, and it has already been designed. Why not take what people have done and learn from it? So we used Google Maps as a base start for our HUD system. And as you can see, Google Maps has multiple different ways of layering their information, and we wanted to take the same kind of idea of how they've layered it. So here's our first concept at that idea of layering information across an entire globe. As you can see on the left-hand side of the concept, we have multiple different layers that we're able to turn on and off depending on the information that the user wants to see at that time. So there they are, highlighted. And then here's how we've actually implemented it into hardware shipbreakers. We start at the top level with our larger units. So if you pull out the game zoom out as far as you can, those are going to be the priority. Those are kind of the main information at that level. As you zoom in, you're going to get smaller units. They're going to slowly fade in depending on the information that you need at that certain zoom level. And then we're going to get to our third level, which is the information level, where we're going to be showing quests, points of interest, maybe little blurbs of information that help guide the player through the map. Oh, sorry. And then our next level is strategic level. This is kind of a white outline contour of the actual map area around them. So when you pulled out so far, it's really hard to see the actual geo of the map because it's kind of like a satellite view. So we want to let the player know where they can go, where the boundaries are, up ramps, down ramps, kind of things like that. And then we have our final level, which is the game geo, which has our texture and our actual geography. So I'll pass this off to Gerald to talk about some of the HUD.
Cool. So our game has been in development for a couple of years now. Like I said, I was involved since the very inception. So I'm going to kind of walk you through the evolution and kind of show you guys how we came from something very simple like this to something very complex. So this is 6 guys in a garage, a week's time. This is a proof of concept. We're all working for free, trying to figure out what's it going to take to make kind of like an interesting planetary scale real-time strategy game. At this point, we were supposed to be a Facebook-based social game. And Unity was also very young and didn't really have any third-party UI tools. So we did what programmers do, and we wrote pixel shaders. These disks that you see on the screen are actually just rendered quads that use r squared equals x squared plus y squared to kind of draw a circle on it, on the disk on the plane. So we're using that as a basic representation of all our units in here. So in terms of developer empowerment, it wasn't that great since it was totally pixel shader driven. There was absolutely no what you see is what you get editing functionality. This is a major thing nowadays, especially something we wish we had back then, where anyone can kind of go in, they can edit things, they can edit prefabs, move them in screen space, and figure out what is it going to look like before I actually hit play and run the game. And this, you could only actually see the icons when you're running the game. Debugging this was a pain, since a lot of the magic happens inside the graphics card, rendering our pixels and the pixel shaders. So it didn't really satisfy the requirement of easy debugging. And for developer empowerment, well, you want to change the representation of our units in our heads-up display? Well, talk to a programmer, because the only way to change that is to change your equation for either a circle, ellipse, or a box in our pixel shaders at this point. But there's a big but here, is we started to kind of wrap our heads around the idea of how we're going to kind of organize our information into different layers. So you can kind of see things popping in and out as the camera zooms in and out of the plane in here. And obviously, this is just not good enough to work in a game. But I thought at least you guys should see where we started from and very humble origins for the game. So we took what we learned. We hired some artists to actually build us some textures and get us some fonts. And you can see the game's user experience and the whole visual look is kind of starting to develop. You can see a bit more varied terrain in here. You can see we've adopted a yellow on tan user experience, which probably wasn't the best for readability, but that's not what I'm here to talk about. I'm here to talk about the heads-up display and things. So what we learned here is we can now set the textures for the actual icons themselves. You can see they even have little labels and stuff like that. And we were using Unity's on GUI at this point, so we hadn't yet adopted a third-party UI solution. We were primarily developing our entire heads-up display inside of Unity's on GUI. This, of course, doesn't yield us a very simple what you see is what you get editing functionality. And debugging, of course, the only way to do this was to pull a programmer aside and ask him why it wasn't working correctly, open up Monodevelop, attach your debugger, and step through line by line to figure out exactly where things are being drawn, why they're being drawn this way, and which colors they are. But we had a very small victory in that only 95% of this was now programmer-centric. It's not a very big one, but it's definitely there. So what we allowed the artists to do is they can now set the texture of the individual icons for our units, which is ultimately not very much. Also, since we're using Unity's on GUI, we can now get access to mouse position and actually provide some kind of feedback for like mouse over and click events. And it also allowed us to kind of do icon state transitions, so we can kind of scale on mouse over or pop out into nothingness when they disappear, which is also something very interesting that we started exploring when it comes to our user experience. And of course, we're even further refining our idea of layered organization and how to build these guys into contextual layers to kind of present them as we move in and out from the planet's surface. But of course, this still isn't living up to our expectations of delivering a AAA user experience. So let's enter phase 3. We discovered that there are actually some decent third-party UI tools, but at the time we finally decided to bite the bullet and get one. We spent some time researching the asset store and whatever was available to us at the time, and we found a pretty good solution. It's called EasyGUI. You may or may not be familiar with it, but we used it for quite a long time. And you can see it definitely added a lot more depth to our user interface and user experience, especially our heads-up display. So you can see our icons, they have much richer feedback. There's health bars, they have color differentiation, and there's even more little bits popping up, just like the salvage icons, those little pluses out there on the screen. So, like I said, this was our first stab at our third-party user interface integration, so we learned a lot in these iterations, kind of figure out, like, how do we make our code flexible enough to withstand these technology changes without having to rewrite every single script in our game that drives our user interface. What you see is what you get editing. This was the biggest feature that came to us. It was a major revelation for us since we were struggling really hard with figuring out how to set screen percents and add anchors and moving things inside the user interface camera. So debugging still wasn't totally perfect, but it was a lot easier and a lot more design and art driven, where you could actually view the transitions and how they were working from Unity editor scripts. And we succeeded in actually empowering our artists and designers to drive the user experience, the different animations and transitions and color changes. So that was a great victory for that. But a major issue with this particular third-party tool, in our case, was at least, it led to some not very easily parallelizable workflows. They used some monolithic sprite atlases, unfortunately, which made it very difficult for 4 or 5 artists to kind of get into our user interface and heads-up display and change things at will. And it was very much designed for a user interface where a lot of these buttons and panels were designed with very specific icon transitions for like mouse over states and click states and enabled states. And a heads-up display, while it embodies a lot of those transitions, we wanted to do a lot more with it. So we're almost there. So what happened? Well, we sat there and we iterated and iterated and iterated and iterated, and I probably wrote our entire user interface about 8 times before we finally arrived at a good solution. We actually ended up changing tools to NGUI, which is a Renmux product, which we found to be quite useful and offered us a different way of looking at and utilizing user interfaces inside of Unity. So I'm going to show you guys what our nth GUI iteration kind of looks like inside of our game, and I'll have Lance kind of walk you through it.
Cool. All right, so we'll get Jared to open up Unity. And here we are. So we've got the game view on the top and the scene view on the bottom, just so we can organize it a little nicely. And so, as you can see, we have our HUD icons right at the bottom. So Jared, let's click on one of those HUD icons, and let's go through kind of how they're set up in our hierarchy. We'll pause the game there. All right, so we have our layers level right there in the hierarchy, which allows us to just organize every unit underneath that layers. Then we can go to the specific units, specific unit there. And then here we have our NGUI icon controller. This is kind of the state or the place where all the variables are being held that are being brought across from the actual unit's prefab. And as you can see, we actually have visual debugging right there on the NGUI icon controller. You can see each icon is colored specifically to the color that they are in the actual game view, or the game view as well as the scene view. And if we turn on the visual debugging or the variable debugging, which Gerald's already done, we can see at the very bottom the variables that are actually being fed into this icon. So this actually empowers me as an artist to be able to, without having to grab Gerald or a programmer, actually see what information is being fed into our system, step through it, and find any problems that might be there. Oh, we need an update. All right, and then what we're going to do is we're actually going to grab one of our units. We're going to send him off into no man's land, and hopefully he'll get in a fight so we can see some real action happening. There we go. Here he's moving. You can see down in the scene view the actual icon moving in a two-dimensional direction off into the way we want him to go. Here he goes. Nice little sexy view. So what we're going to do here is we're going to show the health bar variable. That's actually being held on a separate HUD layer, just due to the fact of some of what the designers wanted to do with that information. So Joe's going to click on the health bar, and we can actually see the actual sprite right here, but we're going to go down to its NGUI icon controller. And we can see now we have the health, and we have its float value at the very bottom. And we're able to, at runtime, watch these variables. As you can see, I guess it's a little small for you guys, but that variable's changing as the unit's being attacked. And that way, I'm actually able to go in, debug these things visually without having to pull on a programmer, see what numbers are being actually pushed in. And as those numbers go down, you'll see the health bar actually change color. And the color, we have the variable right there, so we're actually able to see these things, debug them, and that way I don't have to actually annoy a programmer whenever we need someone. And he's dead. Oh, that's too bad. All right. And let's just pause and zoom in a little bit, get a little bit of, we're going to show off some of the layering effects as we move the unit around. Oh, and he spawned a bunch of units too. So here we go, nice full screen view. And we're going to pause it, which allows us to just kind of slowly zoom in and really see those units. You see how they popped out. What we're really going for here is kind of, as you can see the model, you don't really need an icon anymore. So we'll pull away those icons using a gradient blend of alpha. And then all that information is being fed into our NGUI icon controller, which makes it really powerful for me as an artist, because I can go in, I can edit these numbers, I can do whatever I need to make them look the best they can. Yeah, that looks really sexy. Awesome. Anything else you wanted to show? No?
Cool.
Uh-oh.
Whoa.
And there.
And go. Okay,
Sweet.
Perfect.
So here's the technical brief.
Yeah, so you've all seen kind of the end result of where the iterations of our heads-up display have gone. The build, yeah, it might have been a little bit of blend, but it's a fairly old build. It's been a bit stripped down, about as much as we could show you guys today. But let's see where we went from the technical side of things. So what you guys saw looks a lot like that, except this is me going absolutely crazy with spawning about 100 different units in our game. And what you're looking at are 100 different icons. They're all moving, they're all milling about, and there's even another 100 individual mini-map icon guy on the bottom left of that screen too. So what you're looking at is actually 200 icons, and each one of those icons actually has a bunch of individual GUI elements associated with them. And I'll show you a bit about what that actually looks like a bit later on, but I want to talk about scalability. So when your creative director or producer comes up to you and says, I want hundreds and hundreds and hundreds of these guys on screen, we really had to spend a lot of time to make sure that we're spending as little time on the CPU and GPU as possible to put all this on screen at once. So we pop open the profiler right here. You can see I've kind of took a moment to highlight how much CPU time our HUD element position update is taking. And yes, it is a little on the high side, but bear in mind this is a worst case scenario where every single icon is moving at exactly the same time. So it was about 1.8 milliseconds, and we have 200 full icons here, which translates to about 9 microseconds per icon. And in my mind, I feel that's a pretty good value, and it allows us to do quite a bit with our heads-up display at a given time. Another great win for us, too, was because of the atlasing and the HUD layers, we can actually group a bunch of icons inside of the layers to actually minimize number of draw calls. So even though we're drawing 200 icons, it's only 10 draw calls, the whole thing. And what we're even looking forward to is Unity's next-gen user interface. We can actually save a lot on our fill rate, too, because it's going to be optimizing the sprite meshes based on their outlines, because we have a lot of empty space that's completely alphaed out in our icons right now. So we're really looking forward to see how much further we can push it with our next generation of UI. So I talked about performance. In order to arrive at that number on our profiler, we had to kind of think carefully about where we're going to spend our CPU cycles and how little we can actually ask for from the game at any given frame. So there's a couple of general rules of thumb we follow. The first of all is pretty obvious, is lazy position updates. You don't want for every single icon in your game to be asking the unit, hey, what position are you? What position are you? You have 200 icons asking that every single frame, your game can get extremely slow. I'm not saying that it's going to consume all your CPU cycles, it's not going to be an optimal way of handling the situation. So in order to accomplish that, either when the camera moves or the unit moves, it's all event-based. So that triggers a position update in our transforms and our NGUI icon controllers to make sure that they actually maintain the same spot in user interface space. And on top of that, all of our transitions and animations and particle system feedback on our icons are actually all event-based. So once again, we just want to completely eliminate polling from the equation, provide as minimal a CPU overhead as possible. And in terms of a memory standpoint, object pooling is also a huge, huge win for us, because there are some very fantastic tools in the asset store which provide us the ability to do easy object pooling using prefabs. And once we utilize that, we're actually able to kind of asynchronously create hundreds and hundreds of icons over about 10 frames without any impact on performance. And of course, something that everyone loves to talk about is Atlas sprites, which sounds like it's going to be automated in the future, but in the end for us allows us to completely reduce the graphics performance overhead. So I talked about a lot of different iterations on our heads-up display, and it kind of forced us to really think about design patterns in software engineering. If any of you were here for the Nurturing Large Projects talk, this is going to be pretty close to what I talked about earlier in that talk, about how we applied a software engineering design pattern to empower developers and make sure our software is as flexible to meet the needs of both design and art at any given moment. So what you're looking at is a way of representing all of our data and code in the game, where what the model is, it's the most pure representation of our game. It's Unity-independent C# code, which could technically run outside of Unity, but which is then kind of adapted for Vue by Unity, which is actually what the Vue model is. It's a transformation of that data, which is presented to Unity in a specific way, which is then picked up by Lance and our other artists and designers to kind of figure out, okay, I've got this data into Unity now. How do I make it look awesome? So these NGUI icon controllers kind of represent the notifications and data binding and commands component in Glue that connects our Vue model to our Vue, which is our user interface. So what I said might seem a little overbearing and seems like it adds a little bit of overhead. And in truth, it may add a little bit, but a lot of it was an upfront cost that we kind of paid to make sure we are as flexible as possible. Because whenever we make a change to the C# game code, which is like our AI and inter-unit interactions, whenever we change that, we don't actually have to modify anything else unless we want to change the way we represent that data. And when that happens, we only have to change that API or that kind of meshing of the gears, which happens between the two different gears. And we only have to make the change in 1 or 2 places at most when we decide to do this operation. So, well, that transition didn't work out the way I remembered. This is also a UML diagram. I'm going to blow through this one because they're very boring to most people who aren't software engineers. And even then, it's pretty boring. So I just want to drive home how we accomplish this kind of this interaction, this layered kind of architecture. So the very base level, we have our AI units, which are pure C# objects. And then we have a transformation of that data into something which is easily represented and modifiable and tunable within Unity, which are our unit views. And I threw in map indicators just as another example. And for all these view models, we have the view, which is the glue of our user interface between our view model and the third-party tool we're using. So it's a very, very thin layer of abstraction that when we change our UI solution, we only have to rewrite this one layer. Everything else stays the same. So in the future, if we choose to change the tool, it should be not that much of a rewrite. I mean, yes, it'll take a bit of time, but we don't have to re-architect everything from the bottom layer up to our view to change it. And of course, we have our UI implementation. But our talk focuses on how these guys kind of interact. So we talked about icon controllers in the demo that Lance showed you guys. So I'll kind of just go through how we designed this editor to kind of empower our developers and kind of just make the whole experience very smooth for them. So the glue that binds our view model and our view is actually called variables. So it's kind of like a contractual relationship between the way that we've designed the data in the model and how Unity is going to present it to our user interface. So this is the one thing that if we want to change the data we represent, we may have to bug a coder really quickly to say, I just want to add this integer to user interface, which may not have been thought of in the first place. So a variable must have a unique name which represents this contract between your view model and the view. And then you have multiple ways of binding this variable. And this is actually kind of an interesting exercise because depending on what you slot into these kind of these slots, it changes the way you represent your data and your information. I'll show you guys what exactly I mean by that in a bit of the next slide. And finally, debugging. We want all of our artists and designers to quickly, at a glance, understand what is being fed into this guy and how can I, by myself, without programmer help, figuring out what went wrong and how can I fix it. And yes, sometimes it comes down to a bug in the model code or something like that. But more often than not, it's just a bad link or some bad data which is entered somewhere. So variables. This is kind of the expanded form of that map icon we were kind of exploring in the demo before. And we can actually see that it's not the most simple thing in the world. There's a bunch of GUI elements, and I talked about the 200 icons, and there's like 8 elements or something like that in each one of them. They can get quite complex, and this is the worst case scenario, actually, for our units. So you can see this is kind of like how our artist is going to modify the data, change the representation. They're going to add and remove GUI elements and then hook them up into the data bindings or different variables to change the look and feel of everything. And then when I talked about how we're going to change the visualization of the data, we have these UI hooks right here. So for example, say health bars aren't enough anymore, and I want to be able to represent a unit's health as an actual piece of text. We can actually just add a new label to our icon controller as a child and hook it up into the actual variable as a data binding. And then we can set a format for it so we can choose how we want to represent that data. And voila, we have the same data with 2 ways of displaying it. Now, this obviously doesn't work for every piece of data. Like, for instance, you can't display a string as a slider or something like that, at least. It doesn't work for every situation, but we try to make it as flexible as possible for artists and designers. Input. This is a complex one, because as we're designing complex icons with many GUI elements, each one of these guys are valid from the user interface standpoint as being able to bubble input events up into our game code itself. And it was an interesting problem to kind of figure out at first, because we have to figure out which of these guys is valid for actually telling our game this icon has been moused over or this button has been clicked. So the way we solve that is we'll take a look at the way that we have the prefab structured again, and we kind of identify where the source of this inputs that we want to bubble into our game exists. And we just attach a script called an event handler, which is going to actually grab that information and bubble it up to the icon controller itself and send it off into our actual game code.
All right, so I'm actually going to go through my workflow as an artist. Pretty straightforward. First thing I do, I grab whatever asset I need out of whatever program I've created. I bring it into our project folder. And the important part here is naming conventions, making sure that we have everything organized in a way that makes sense to the whole organization, or any artist or designer. So here you can see this is the units folder. Above this is actually the map icons folder. So everybody underneath this knows that they are a map icon. But even further, each asset is named map icon as a prefix so that there's no way you can mistake what this thing is supposed to be for. Then we have our actual name of that unit. And this is globally defined throughout the whole game. So every unit has a specific name that's used throughout the whole thing. So next we want to add it to the atlas. We'll grab that specific PNG. We'll grab our atlas. And because of the solution we're using with NGUI, it's a straight just add or update to that atlas. And this allows us to make quick iterations on any type of icon, map icon, information icon, any type of icon that we have in the game. And then we have our actual unit prefab. This is the player's escort light, MO1, basic 01. And inside, he has his unit script. And underneath that, we have our HUD attributes. And inside there, we have our icon names. This is just a string name of the original PNG that we brought in at the very beginning. And this is going to reference straight back to our map icon atlas that we've already added this thing to. And now we'll see, once running the game, we're going to start debugging to make sure all this information has been brought across properly. So now, game's running, our icon is created, our NGUI icon controller is holding our information, and if we turned on the variable debugging right here, we'd actually see the next row, which would actually show us exactly what string is being brought to this NGUI icon controller. And then here is the final confirmation. We go to that specific sprite that's being referenced inside the NGUI icon controller, and we're able to see the sprite name that it's pulling off the atlas is the original name that we inputted at the very beginning. And this is a step-by-step process. That way we're able to know exactly what information is going where, the color, and you can see at the bottom with the preview, this is the exact same picture that I brought in at the very beginning. So what we're going to do just before we end off is jump into the game for a second.
Yeah, so we're a bit ahead of time here today, so we're going to spend a bit more time and go blow some stuff up in the game and show you guys some awesome effects. If it decides to start up again.
There we go.
I think there's an enemy base over here.
Yeah. So as you can see, this is kind of...
Somebody checked in some bad camera settings too, so forgive that.
So again, what we're trying to do with this whole layering system is making sure that icons kind of know the information that they need to know. They're off when we've got enough of a 3D object. We don't really need the icons anymore. You can click straight on the object. And also, as we get closer, you notice the icons will actually lift above their unit just a little bit, so we get a little bit of plating above that unit. And all this information is brought over straight from the unit prefab into the NGUI icon controller. And we can zoom out all the way, and you'll see the smaller units will reduce into dots.
Enemy base there. That's why you don't do live demos all the time. Sometimes it just doesn't work.
So I guess we'll just zoom in on them and have them blow up.
Sorry, we can blow up a bunch of stuff anyways.
OK. So there we go. And there's a big explosion. Everybody falls to the ground. That's too bad.
Yeah.
All right. And jump back in here.
So yeah, we're opening up the floor. Any questions? Anything you guys would like to know more about our development process and our heads-up display?
There's
two microphones on either side and either aisle. If you'd like to ask a question, just run up there because this is being recorded. Like you guys to hear what your questions are. And oh yes, our slides are freely available, so if you'd like to see what we talked about up close, please check out the link.
Cool.
Yes, go ahead.
I was working on something where I was trying to attach player names, to all of my players, similar to how you had your icon above your ships. I was wondering how you're manipulating that transform so that it moves across the panel, and updates, because I assume you just have one panel with all of those on there with NGUI?
Yeah, so what we have to do is basically unproject I'll backtrack one little bit more. We have two cameras in the game, obviously, so we have one down-facing camera, which represents our game camera, looking at our game geometry and all the units and stuff like that. And then we have to figure out where that unit is within that camera frustum and unproject him in a 2D space. And then we have to reproject that into the NGUI camera on that panel and set the icon's position within that panel to get it to line up perfectly. Now, that necessarily isn't enough sometimes, because you'll find that there might be a lag between the two, or the icon might seem to trail the unit in screen space. It's very important to do that untransform and retransform to find the icon position after you've moved all your units or all your transforms in the game. Otherwise, that lag effect will present itself.
Cool, thanks.
Cool.
Hey, so I noticed that at the very end there, you had a nice topographical almost display when you zoomed out a little further, and it had some nice, really crisp lines. What are you using to draw those?
Well, ideally, we'd like to use some kind of vector graphics, but the truth is, it's just a texture. It's a 4K texture right now.
Hand painted.
It was a quick prototype we threw together just to see what those kind of lines would look like. But we do want to do something vector graphics at some point for that.
I saw that you had a certain number of layers and that they were all the same size. I mean, could you, if you wanted to, have certain layers that were local to certain parts of the world, or do they all have to be the same size?
Do you want to handle that, Lance?
I'm not quite sure.
Okay, so maybe it wasn't totally clear in the way we represented that information. I mean, a layer's space is technically infinite.
Right.
Its space is exactly which icons are within it and where they are inside of your screen space. So we have this notion of culling where the HUD layers have some kind of screen space size, and if they're not visually represented in the UI camera, they'll be clipped and things won't be shown and stuff like that. So ideally, they can be an arbitrary size depending on whatever icons we stuff inside of the layers.
Okay, I see that. Thanks.
Yep. Nope, go ahead.
How are you doing your fog of war?
The fog of war is kind of an interesting thing. It evolved a lot from when our game was actually on a 2D plane, where we were drawing using the same shaders actually as the original icons to draw disks. They basically punch out holes through a screen space, well, not a screen space, like an image effect, basically. So we were writing to the depth buffer, basically invalidating a zone, almost like a stencil buffer, which we didn't have access to until just very recently, to effectively punch out a hole inside of a colored overlay on the screen. And these disks, they lay in the same plane as the ground plane itself, so when you rotate and orbit the camera, they're going to look like they more or less cover the right space. But it's not the final implementation we want, but it's worked for us just to kind of show fog of war for the meantime.
Hey guys, I was wondering if during your various adventures with third-party UI tools, what other things you tried and why you found them lacking. Specifically, I'm kind of curious if you tried any of the Flash to Unity conversion solutions like Uniswift or Scalable.
Sorry, can you repeat that a bit louder, please?
Sorry.
There we go.
When you guys were trying third-party UI tools, what else did you look at? What were the problems you found with them? And did you try anything like either Uniswift or Scaleform or some sort of Flash to Unity UI conversion? Yeah,
we did sign up for the Scaleform beta, and we're actually intensely interested in Scaleform itself. Unfortunately, there's an inherent business cost associated with it because you need to have the Flash development platform in addition to the Scaleform license. And at the time, we weren't willing to put the cash up front to really deeply investigate that platform. As awesome and fantastic Flash UI can be, I mean, I personally have worked with a lot of Flash UI in previous projects. Having used EasyGUI, it was a great solution that I talked about, but in the end, it just didn't quite meet our needs. But in truth, we didn't really explore a whole lot of other options. Lance had a lot of experience with NGUI, and it just seemed to kind of work extremely well with the kind of user experience and developer needs that we had at that time.
Yeah.
Thanks.
No problem.
So did you guys write an actual data binder to do your data updates between your UI elements? How was that handled, like to update the labels, text, or position of a slider?
Yes, so it's a fairly lightweight, thin class, which is that NGUI icon controller script. It basically has a public API where you want to set a variable's data either as an integer, a string, or a float. And depending on what you've hooked up for the data bindings there, it's going to understand how to set the data in that corresponding GUI element.
And does it do that update every frame, or is it always in response
No,
to an event?
only when the data changes does it actually update it.
Okay. One other question about, can you talk a bit about your minimap implementation?
What do you want to know?
Similar things. Is that only updated position when the event fires, or did you have performance problems with it?
That guy is a little different. In all truth, the icons, like the little blips themselves, run on the exact same HUD layer system as the rest of our game, but the map itself and the fog of war are updated about 10 hertz. Have a pretty lazy and brute force implementation of it right now, but it's just something I whipped together really quickly to show off on the mini-map.
Okay, thanks.
Yep.
So we're still over here.
Would you guys be using a vector source for your icons, or would you be using raster images? And would there be any problems with scaling if you were using raster?
We are using raster at the moment right now. Mostly how it's going to probably be working, we're going to be going with like an HD atlas and then an SD atlas, depending on what resolution you're going to be running the game at. Unfortunately, we just haven't had any vector stuff in the game, and NGUI only runs on rastered images, so.
Cool, thanks.
No problem.
So I saw that you can control what kind of units you're seeing by like adding or subtracting layers. I was thinking if you consider like more customizable ways, like letting the user choose exactly what kind of units they're seeing.
Yep. In the original concept itself, we had this notion of a checkbox that basically listed every layer which you could look at in groups of layers, where you could turn them on and off, just like Google Maps itself. It is part of the concept that just there's no implementation to go in there. It is totally possible from code to do that right now. We just haven't exposed the UI hooks at this stage in development to kind of do that.
Oh, I see.
One thing right now is also our health bars are actually set up that way. They can be turned on and off, toggled through a button. So.
I see. Thank you.
No problem.
Hi, I have a question about your event-driven design. Did you use an asynchronous design pattern or Unity messages or anything else? We used
vanilla C# messages for a lot of this stuff. And we also have a synchronous messaging system in our game, which is a large event system where we fire events which are picked up by any kind of subscribers and stuff like that.
Is that a custom written system written by
yeah, the event system we wrote it's custom, but it's a fairly straightforward process where basically you just use generics to store a subscriber to a specific message, and we have a bunch of messages we can publish.
I guess just observer pattern, right?
Yeah, essentially.
All right. Thank you.
Cool.
Anyone else?
Anything else? Cool. Well, thank you very much, everybody.
Thank you. Oh, yeah. We're hiring.
And don't forget the slides are available, and don't be afraid to share it.
Yes.